Welcome back to another episode of my proof series where I will be showing you why certain things happen in mathematics. This lesson will be focusing on why the inverse of sec x or the arcsec x, they're both the same thing. When you derive them, you get 1 over x multiplied by the square root of x squared minus 1. Okay, so let's start with our function. We're going to call it, oh that's bad, f(x). Okay, and that will equal sec inverse x. I hope that's not too faint. Okay, and now we have this. What we've got to try and do is isolate x. So we're going to bring the sec over this side. How do we isolate x and do that at the same time? Well, just like, if you're familiar with trigonometric functions and moving them around when you're solving for triangles, this should be familiar. But this is what we will end up with. Okay? It's just like if you had something here and you knew it and you had sec but you didn't know the angle, you would have to put multiply by the inverse on either side. Okay, so I'm essentially multiplying each side by sec, essentially, sorta. But anyway, so now we've got this works. Okay, so we're going to find the derivative of either side. The derivative of sec fx, we use the chain rule. And we start with deriving the outside, and then we multiply by the derivative of the inside. So, derivative of sec fx is going to be sec fx multiplied by tan fx. All that is just the derivative of sec fx. And now we're going to multiply by the derivative of the inside, which is going to be derivative of fx. Now, that equals the derivative of x, which is just 1. Okay? Now that we have this, let's rearrange it a bit to get f dash x on its own. All that we'll need is just to divide both sides by sec fx multiplied by tan fx. Okay. Now that we have this, what I'm going to do, and this, I'm not going to explain it now, but it leads on, I'll do it, and I'll show you why I did it in a few steps. So, I'm going to square root the bottom, and in order to do that, with having it still equal the same thing, means I have to square it. Each of them, because the squared on each of these and the square root cancel out, and that equals that there, but I need there to be square roots and I need there to be squared. I need these to be squared, and the only way I can do that is by square rooting it as well for now. Okay, so we have f dash x, so let's rewrite that, f dash x. Okay, now what I'm going to do now is split them up. And that's going to look like 1 over square root of sec fx squared multiplied by square root of tan squared fx. Okay, this equals the same thing. When you multiply these together, you get this. All I'm doing is just rearranging and chopping and changing. I haven't really done too much yet. Now, what I'm going to do here is we're going to try and, well, first of all, I don't want to change this. I'm just going to leave it as sec fx. I'm going to convert it back. So the squared will cancel out the square root and we'll end up with this. But I want to do something with this. Now, there's a trigonometric identity, and it will look like 1 plus tan theta equals tan squared theta equals sec squared theta. Now, I can change this so it'll look like 1 plus tan squared fx equals sec squared fx. Now, why can I do that? Because it doesn't matter what the variables are, as long as they're the same. Like there's 2 thetas and there's 2 fx's. That's all we need for this to be true. Okay, now I want to get tan squared fx on its own. So how will I do that? I will subtract 1 on the other side. And what we're left with is sec squared fx minus 1. Okay? Now this is good because we have a tan squared fx. Okay? So if we use this, sec squared fx minus 1 equals tan squared fx, that's what we're going to sub in. So we're going to end up with the square root of sec squared fx minus 1. I hope that's not too faint. Okay? All I did was sub in tan squared fx for this. Now, we established earlier that, I can find it, it's here, that sec fx equals x. Okay? Sec fx must equal x. So first we have 1 over x, because these x and sec fx equal the same thing, square root. If x equals sec fx, then sec squared fx must equal x squared. Okay? And then we have a minus 1. Okay? Because if we had if we were to have this, sec fx equals x, if we were to square one side, we would have to square the other side. Therefore, sec squared fx equals x squared. See? Sec equals x, and sec squared equals x squared. Okay, I'm going to rewrite this, and it's going to look like the derivative, the function we started with was sec inverse x, and we finished with 1 over x square root of x squared minus 1. Thanks for watching. I hope you learned something, and have a good day.